So if we look at lesson number 6 takes lesson number 4 and 5 and uses the graphic calculator to solve them. Instead of referring back to the z-score tables, your calculator has been basically programmed to have the z-score table in the calculator. So there is a function called normal CDF. There's one that says normal PDF. You want the one that says CDF. That's the important part. This calculates the area probability between two z-score values. So it has to do with normal distribution. So the probability to the nearest tenth of a percent that a data value lies in the interval of the mean minus 0.85 standard deviations to the mean plus 2.31 standard deviations is what? So if we show the information on a normal curve, there's where my 0 is, that's my mean, and then I have 0.85 standard deviations below and 2.31 above. So if I grab my calculator, I access that normal distribution menu by pressing the second and the bars button. Now, the hardest part is where do I find all of this stuff? Because if I can't remember that it's second bars and I start to freak out, I don't know where to find it. What I can do is if I go second and the 0 button, in blue above it, it says catalog. The catalog comes up. And it's in alphanumeric form. So if I want to go to normal CDF, I find the letter N, which I think is the log button. And if I press log, it jumps down to the ends. And then I can use my arrow to scroll down, and there's my normal CDF. The other thing that you need to remember with normal CDF, which stands for normal cumulative distribution function, is they want it to be written as the lower boundary z-score, the upper boundary z-score. So I need a start and a finish. So in my question, I went from negative 0.85 to, so I use a comma button, 2.31. And then I press enter, and there comes my 0.791893, etc. So as a probability, this is 0.7918. As a percentage, I would multiply that number by 100, and I would get 79%. So 79% of the data lies between those two z-scores. Well, in some of the questions that we had, we were given a question and you drew the curve, and maybe this was my mean. Maybe I had something where I had to go and find all of this. So I have this boundary, I have what this z-score is, but I don't have a z-score here because it goes on indefinitely. Well, think of that as being an extremely small number. Now, when we get into some of the problem solving, we could possibly figure that out or put that in. For example, the flu question that we had. Remember the flu question with the percentage that would last between this many days and this many days? Well, my lower extreme would be 0 days. So that would be my lower boundary would be 0. My upper boundary, if I had to go the other way, think of some ridiculous number. Honestly, if you have the flu for 365 days, are you really going to be with us anymore? You cannot have the flu for a year straight and actually maintain your health. Something's terribly wrong in that case. So I could go up to 365. The notes that are in the workbook say that if you're going to the right, you can use a score such as 10 to the power of 99, which means 10 times itself 99 times. It's a huge number. Or I could go 10 times, or 10 to the power of, sorry, not 10, negative 10 to the power of 99. So that's an extremely small number. Most of the questions that we have are given to us in a problem-solving scenario where we could determine the upper and the lower boundary through logical reasoning. The other thing, the answers are not going to be exactly the same as the ones obtained from the table, because this actually has the equation for the normal curve programmed into the calculator, not the z-score table. So this is accurate to far more than 4 decimal places. So let's look at the flu virus example. So in this flu virus example, the mean was 12 days. Standard deviation was 3 days. The data is normally distributed, and you caught this strain of the flu. Determine the probability that it would last longer than 17 days. So what number goes in the middle?
12 days.
12 days. So where would 17 days go? Okay, and standard deviation is 3, so 3 days would give me 15, another 3 would give me 18, so it would be somewhere over here. Which area do I shade? Longer than 17 days. So now when I use my calculator to do this, there are 2 more numbers that I can enter in. So I already have normal CDF up here once. If I go second and the enter button, it puts it in place again, and I can just delete these numbers and start over. So I don't have to rewrite or keep looking up that normal CDF program. So I need the lower bound. 17 is my lower bound. And then I need an upper boundary. The upper boundary being that extreme case. Well, what did I tell you we could use in this case? 365 days. Now, the other nice thing is I don't need to actually convert things into z-score. That first example, we had z-score values. In this one, I don't need to convert into z-scores, but I need to tell the calculator what my mean was and what my standard deviation was. My mean was 12. So I put that in. My standard deviation was 3. So I have to put that in. So that tells the calculator I want to go from 17 days to 365 days with a mean of 12 and a standard deviation of 3. And then I press enter, and I get 0.047779, which gives me like 4.7%. So then if I look at the second example, between 13 and 15 days. So I have 12, then I'm going to have 13, and then I'll have 15. And I want the area between those 2 values. So when we did this manually, we had to find the z-score of 13, and then the area to the left of 13, the z-score of 15, and then the area to the left of 15, and then we subtracted them. With the calculator, second vars, selection number 2. Mine comes up a little bit differently than yours, so I'm actually going to quit that and just go to what was typed before.
That's how mine's like. Yeah, that's how mine's like. That's the one we scored.
Oh, the one that I just did?
Yeah.
Okay. So second vars. So the lower bound, that's where I would put my 13 days.
Oh, no.
The upper boundary, that's where my 15 days would come in. And then mean, 12, standard deviation, 3. And then it says paste. Press enter on paste, and it actually pastes the whole thing in for me. Just a second, I think. Let's try that again. I think I did 2 on top. There we go. And there's my 0.2107, which is what we got when we calculated it out the first time. So I have about a 21% chance of the flu lasting between 13 and 15 days. So let's look at class example number 1, postal outlets. They've determined using standard mail service, it takes 3 weeks on average for a package from China to arrive at an address in Canada. They also determined there was a standard deviation of 5 days and that the times are normally distributed. meaning that on average they arrive in 3 weeks, but I have some that arrive a lot faster and some that are a lot slower. So it says determine the probability to the nearest hundredth that a package will take less than 15 days to be delivered. So if this is given to me in 15 days, I have 3 weeks and I have 5 days. I need to change 3 weeks into days. How many days would that be? 21 days. So 21 days is my average. That's what goes in the middle. And determine the probability that a package will take less than 5 days to be delivered. So 5 is going to go to the left of 21, and then I'm going to shade the area to the left of that. So when I go to put this into my calculator, normal CDF, what is the lower boundary? So it's the least number of days it could possibly take. 0 days. I don't even need to worry about negatives, it doesn't make sense. 0 really doesn't make sense, but anything less than 0, I can't time travel. And then my upper boundary would be 15 days. My average, standard deviation. Okay, so let's put that into the calculator and see what we get. So 0, 15, 21, 5. And I get 0.11505. Or so, no, 11505, right? So the probability to the nearest hundredth would be what?
0.11.
Nearest hundredth would be 2 decimal places. 0.12. Okay? Postal outlets guarantee that a package will arrive in less than 35 days, otherwise it's free. Last month, there was 8,257 packages sent from China. How many would be expected to be delivered for free? So what goes in the middle? The middle of my curve will always be the mean. And what is the mean? No. What's the mean delivery time for a package from China?
Less than 35 days.
Go back to the original question right at the top. On average, how long does it take to deliver a package?
21 days.
21 days. That's what goes in the middle. I need a delivery in less than 35. If it is more than 35 days, it's going to be free. So do I want to shade the stuff less than 35 or more than 35? More. This is the part that I'm interested in. I want to know what probability is more than that. So my normal CDF, what would my lower boundary be this time? What's my upper boundary? 365 would be a good one. If it takes more than a year, it's probably lost. My mean and my standard deviation. It's still 5. So that's what I put into the calculator, and I want you to tell me what you get. So 0.002555, that's the probability. So the probability that a package will take more than 35 days is like 0.2%. Multiply that by the 8,257. So what do I get when I multiply these two numbers together?
21.0982. 0920.
So 21 packages I could expect to be delivered free of charge. Class example number 2. Calculate the percentage of the population to the nearest tenth whose height is more than 1 standard deviation above the average height of the population. One standard deviation taller than that. There's one standard deviation. So I want that section. In this example, my lower bound is 1. My upper bound, I could let be 100, 1,000. 100 would mean 100 standard deviations away from the mean. Am I given the mean this time has a number? No. But I am told that it's distributed. So the height is more than 1 standard deviation above the average. If I'm not given a mean and a standard deviation, I can use 0 and 1. Now, with this programming, I can put the 0 and 1 in, or I can leave them out. If all I put in was normal CDF 1 and 100 and pressed enter, what would I get? Let's put that in. We went 1, 100, 0.1586. We're going to write that down.
I can't get to that, like I have to use that. Negative.
You have to use the 0 and the 1.
Yeah.
And if I put in the 0 and the 1, does it change the answer?
No.
Nope, same answer. So the default of the calculator is if you don't put in the average and the standard deviation, it writes them down as being 0 and 1. So the percentage of the population whose height is more than 1 standard deviation above the normal is 15.9. So about 16% of the population is more than 1 standard deviation taller than the average. Okay, that is how to use the calculator to find the area. The next part, gentlemen, gives you the area and asks you to find the value. So if you were given the area to the left of a data value, we can use inverse norm to calculate that data value. We need the mean and the standard deviation. So if we look at that Toasty Toaster question that we did last time. Toasty Toasters knows that the average lifespan of their toasters is 4.2 years and the standard deviation is 0.65 years. They want to, or they do not want to replace under warranty more than 8% of the toasters that they sell. So what kind of a warranty should they offer? So if I sketch this, normally distributed data, in the middle goes my average, 4.2. I want to replace 8%, or less than 8%. So that's this area down in here. This is my 8% area, or as a decimal, 0.08. So I find the inverse norm catalog key right where I found the normal CDF by pressing second bars. When I use the inverse norm, I need to give the area to the left, the mean, and the standard deviation. So let's do that. Second bars, inverse norm, And depending on your calculator, it might actually prompt you for pieces. Area, 0.08. Mean, 4.2. Standard deviation, 0.65. And then it pastes that into the question. So what you get? 41.08.
3.2.
Yeah, so, yeah.
What happened there?
Oh, you're just saying right here.
Oh, right here, 42. Let's try that again. 4.2. That makes more sense. 3.2 years. So what kind of a warranty did we say we should give? A 3-year warranty. What's the matter?
41-year warranty.
Yeah, well, that's when it was lasting for 42 years. Something to note, even if the warranty, gentlemen, even if the warranty had fallen between 3.5 and 3.99, I would not round up in this case. I would round down, because rounding up to 4 years, if this was at 3.75, would mean that I would actually be replacing more than 8%. Remember, the company said it doesn't want to replace any more than 8%. It doesn't say that it will replace less than 8%. Less than 8% is a bonus. So, inverse norm can be used to calculate a z-score if the area to the left, if we are given the area to the left of the z-score. If we're using z-scores, the mean is 0 and the standard deviation is 1. So we can use it in a real example, or we can use it using the distribution curve, the standard distribution curve, where the mean is equal to 0 and the standard deviation is equal to 1. So, determine the z-score to the nearest hundredth if 1% of the data lies above the z-score. There's my average. 1% of the data lies above the z-score. So I want this to be above, and my area is 1%, which as a decimal would be 0.01. So in this case, it would be inverse norm, area of 0.01, with 0 and 1 being my mean and standard deviation. Tell me what you get.
Negative 2.3.
Should be negative. Oh, sorry. I screwed up. I made a mistake. Area to the left. So if 1% is above, what is below?
99.
99. So below is 99%. So my inverse norm should be 0.99, 0, and 1. My bad.
So 2.3.
So to the nearest hundredth, 2 decimal places, 2.33.
3.
Okay, so your questions, question number 2 and 4, that's the normal CDF stuff. Questions 6 and 8 should be the inverse norm, and then 9 and 10 could be either one.